publish tools once and reuse them across clients. Here is a Model Context Protocol, or MCP, demo with one tool and one resource. If your projects keep re-implementing the same helpers for different models, you waste time and introduce bugs. Today, you will see a tiny practical pattern that centralizes a document resource and a single search tool, so you can reuse them across workflows. By the end, you will understand how to seed a local doc set, build a simple inverted index, add basic search, filter noise with stopwords, and register one tool with one resource in an MCP-like map. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple concepts-first Python that helps you solve bigger real-world problems. We will use a single small corpus of 3 short mock documents. The idea is to keep the data tiny, so the mechanics are clear. The doc resource will live locally in memory. The tool will be a search function that looks up terms in an inverted index and ranks by hits. This is not a production search engine. It is a pattern you can extend to larger collections or a vector store. Now let us seed that local corpus. This snippet seeds a docs resource with 3 short mock entries. This snippet creates a simple list of documents and assigns each one a stable identifier and a short text field so downstream code can refer to them by ID. The top of the snippet defines the docs container and appends 3 entries in order. Each entry is small and human-readable, so you can inspect what the search should match. The purpose is clarity. Have a predictable, tiny corpus, so the rest of the demo operates deterministically. The snippet ends by returning or exposing that docs list for the rest of the process to consume. Next, we will turn raw text into lookup-friendly pieces. This snippet tokenizes text and builds an inverted index for docs. This snippet walks through each document, lowers the text, splits it into tokens, and then maps each token to the document identifiers where it appears. The inverted index is a dictionary-style map from token to a posting list that holds doc IDs and simple counts. The snippet handles basic normalization and accumulates term frequencies so a later scorer can use hit counts. It also shows where you could add more normalization, for example stripping punctuation or applying stemming, but keeps the code intentionally simple so the mechanics are obvious. The resulting index is lightweight and can be inspected in memory. Now we need a tool that actually uses that index to answer queries. This snippet implements a search docs tool that ranks docs by term hits. This snippet defines a callable search function that accepts a query string, tokenizes it in the same way as the index, and then looks up each token in the inverted index to collect matching document IDs and scores. The scoring rule is straightforward. Sum the hits for each matching term, so documents with more matching tokens score higher. The code then sorts the results by score in descending order and returns the top matches. The function also accepts a parameter to limit how many results are returned. So increasing that limit gives you more candidates, but may lower the relevance of the final list. This produces a simple, explainable ranking you can reason about. Next, we will reduce noise to make matches clearer. This snippet removes common stopwords to reduce noise and improve focus. This snippet augments the tokenizer by checking tokens against a small stopword set and skipping any that appear there. Common words like the and are typical stopwords we drop because they do not help rank documents. The code shows where to define that stopword set and how to filter tokens before they are added to the inverted index or used in queries. Removing stopwords reduces false positives and speeds up lookups when the corpus is larger. The snippet keeps the stop word list intentionally short, so you can see the effect. And it is easy to expand it later, if needed. Finally, we wire the pieces into a tiny MCP-style map. This snippet registers one tool and one resource in a tiny MCP-style map. This snippet builds a small registry object that maps human-friendly names to the docs resource and to the search tool callable. The registration is explicit, so any client or agent can request the docs resource or invoke the search tool by name. The code shows how to store the resource reference and the function pointer, and how to look them up from the map. This pattern centralizes access, so you can reuse the same search tool and the same local docs across multiple workflows without reinitializing them each time. It also sets up a clear extension point for additional tools or resources. At this point, you can imagine plugging the search tool into an agent or calling it from different scripts. In a real system, you would replace the in-memory list with a persistent store, or swap the inverted index for a vector index when you scale. Quick recap. It is a tiny MCP pattern that seeds a docs resource, builds an inverted index, and exposes a named search tool. Use it when you want a simple, reusable, local search for testing or prototyping. One caveat: this simple ranking by term hits will not handle synonyms or semantic matches. Next step, scale this exact pipeline by swapping the inverted index for an approximate nearest neighbor index, and measure how retrieval quality and latency change. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.